Hello viewers, welcome to my channel, Second Math Hub, the solution to your math problems. Still on trig, application of trig. This is our last question and the application of trig. I read, a tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees with the ground. So we can quickly represent the first statement. So we have a tree which has been broken due to a storm. So obviously the tree will be erected on a level ground. So let me represent, or let me draw the tree. We're told that this tree got bent due to a storm. So let me draw the bent part. Okay, so we have our broken tree. We have our broken tree, and we are told that the top of the tree touches the ground, making an angle of 30 degrees with the ground. So the angle here measures 30 degrees. The angle here measures 30 degrees. And again, we're told that the distance between the foot of the tree. So where is the foot of the tree? There's the foot of the tree. The distance between the foot of the tree to the point where the top touches the ground. So to the point where the top of the tree touches the ground measures 8 meters. So this distance here measures 8 meters. So from here to here it measures 8 meters. So we have to calculate the height of the tree. We have to calculate the height of the tree. So let's quickly transform this into a right angle triangle. We can transform this into a right angle triangle. So let's do that. So this is the first portion of the tree, the base of the tree, and this is the bent part of the tree. And we are told that the top of the tree made an angle of 30 degrees to the ground. And again, you could also see that the base of the tree will meet the ground at an angle of 90 degrees, an angle of 90 degrees. And don't forget that the distance between the foot of the tree to the point where the top of the tree touches the ground measures 8 meters. So this distance here measures 8 meters. And don't forget that we are to label our right angle triangle. So I'm labeling it as A, B, and then C. So now, how do we calculate the height of the tree? So to calculate the height of the tree, we need to measure this height. From the foot of the tree to this point is one part of the height of the tree plus the bent part. So that should give us the full height of the tree. From the foot to the bent part, and then from the bent part here to the top of the tree. So that distance or this height here represents the full height of the tree. So now from our right angle triangle, let's identify the sides of the right angle triangle. So clearly this side here represents the hypotenuse because it is the longest side. Again, it is the side facing the 90 degrees angle. this side here represent the opposite, simply because it's the side facing the acute angle, and then the remaining side will be the adjacent. So now, to make our calculation easier, I'm representing this height of the tree from point A to C as X, and then I'm also representing the remaining height from the bent part to the top of the tree as Y. This will make our calculation very easy. So now, from our triangle, so I'm naming the triangle ABC. Triangle ABC. How do we calculate this height? Line AC. So to calculate line AC, we have to consider our opposite, then we were given the length of the adjacent. So from SOHCAHTOA, which of them has opposite and adjacent? So that is TOA. So mean that to calculate the height from A to C, you must go by TOA. And what does TOA say? TOA says that the tan of this angle here should be equal to the length of the opposite. What is the length of the opposite here? X divided by the length of the adjacent, giving us 8. So tan 30 is the same as tan 30 on 1. We do the cross multiplication. 8 times tan 30. 8 tan 30, and then 1 times x. That should give us x. So from our calculator, what is 8 tan 30? 8 tan 30. So to 2 decimal places, I'm having 4.62 is equal to x. Therefore, x is equal to 4.62 meters. So that is the height of the tree from the foot of the tree to the bent part. But we want the full height of the tree, so we also need to measure, or we need to calculate the height of the tree from the bent part to the top of the tree. So again, from the same triangle, from triangle ABC. Now we want this height. So because we want this height, we have our adjacent. And this height here represents our hypotenuse. So from SOHCAHTOA, which of them has adjacent hypotenuse? So obviously it's CA. So it means that to calculate this height, we must go by CA. And what does CA say? CA says that the cos of this angle here is equal to the length of the adjacent. So this is the length of the adjacent, 8 meters divided by the length of the hypotenuse. And we represented the length of the hypotenuse as y. So let's solve for y. So cos 30 is the same as cos 30 on 1. We can cross multiply. Y times cos 30, that should give us y cos 30. And then 1 times 8, that should give us 8. We are looking for y, so we divide both sides by cos 30. This side too by cos 30. So cos 30 will cancel out, leaving y is equal to. So from our calculator, what is 8 on cos 30? 2 decimal places. That is giving me 9.24 meters. So in conclusion, what is the full height of the tree? So the height of the tree, will be the sum of this distance, that is from A to C, represented as x. And what do we get for x? 4.62 meters plus the height from the bent part to the top of the tree, represented as y. And for y, we had 9.24 meters. And this should give us 4.62 plus 9.24. That is giving us 13.86 meters. So in conclusion, the full height of the tree measures 13.86 meters. Thanks for watching. Don't forget to subscribe to my YouTube channel. So the name on the channel is Sekin Math Hub. So when you open your YouTube channel, or when you open your YouTube on your smartphone, you enter this name on the search area, and then subscribe to my channel. And after subscription, don't forget to share the YouTube link to your colleagues. So thanks for watching. I hope you enjoyed this episode. See you next time.